Welcome back to the deep dive. Today, we're plunging into a document that, well, looks pretty dense at first glance, a performance work statement, or PWS.
Right, for technical and programmatic support.
Exactly. But we're here to peel back those layers, cut through the jargon, and really uncover the hidden complexity behind some essential global government operations.
It's pretty fascinating stuff when you get into it.
Our mission today: extract the key insights. We're talking about maintaining critical electronic mechanical systems, mainly for the U.S. Army, but other agencies too.
Yeah, and the scope is just, well, huge.
What are the real challenges? What makes this work so specialized? That's what we're diving into.
And what's really striking is how this one document outlines such a comprehensive, critical set of services. I mean, from its global reach to these highly specific technical needs and security requirements.
Yeah.
We're going to see just how interdependent these systems are and what it really takes day to day to keep them running smoothly.
Okay, let's unpack this. You think about government ops, maybe keeping the lights on, or cybersecurity doesn't immediately jump to mind in this level of detail. But the precision needed here to make sure these essential systems work as intended, it's kind of astonishing.
It really is.
So the document kicks off saying the contractor provides, personnel, equipment, tools, materials, supervision, all for restoration adjustment services.
Right, for building systems.
That sounds broad.
Yeah.
What are the main service buckets here?
Okay, so basically we're looking at technical and programmatic support services, TPSS. And that focuses on three main areas.
Which are?
Cyber, electronic security systems, that's ESS, and utility monitoring and control systems, UMCS.
Got it.
And the U.S. Army Engineering and Support Center in Huntsville, CEHNC, they act as a center of expertise for this. So they support the Army, but also other DoD and even non-DoD agencies.
Okay, so CEHNC is the hub. And this restoration adjustment, what's the main goal? Is it like bringing a complicated machine back to factory specs?
That's a pretty good analogy, actually.
Yeah.
The main goal is helping bring existing facilities back into compliance, back to their original design intent and, optimal performance.
Okay.
But, and this is important, it's not about major renovations or brand new construction.
Oh, okay.
Yeah, the PWS specifically says no architect engineer services or complex repairs that need a whole new design.
So it's about tweaking and fixing what's already there.
Exactly. Restoring, adjusting, often through minor repairs, alterations, optimizing what exists to meet its original purpose.
And it mentions commissioning, recommissioning, or retro-commissioning. Now, for someone trying to grasp the nitty-gritty, what's the difference there? And, what's the hidden value in retro-commissioning?
Right, good question. So commissioning is usually for new systems, making sure they work right from the start.
Day one.
Recommissioning is doing that again later. But retro-commissioning, that's where it gets interesting. It's more like an investigative audit of an existing building.
An audit? How so?
Well, they might go in and find, say, a ventilation system that should be super efficient, but it's actually running full blast 24/7.
Oh, wow.
Yeah, maybe just because one small sensor is off, Retro-commissioning finds and fixes those hidden problems.
So it saves money. Energy.
Huge potential savings. Energy costs, better climate control. All without ripping out old equipment necessarily. It's about making sure systems, even old ones, perform how they were designed to. Or even better.
Okay, that makes sense. Now, here's where it gets, I think, really interesting, the geographic scale.
Oh, yeah.
This isn't just local work, is it? We're talking global.
Absolutely not local. The contractor has to be ready to handle multiple jobs, diverse locations, all across the continental U.S. CONUS. That includes Alaska, Hawaii, U.S. territory.
That's already big.
And then it goes outside the continental United States CONUS. Specifically calls out Germany, Italy, Japan, South Korea.
That's a massive footprint.
It's immense.
What does that kind of reach tell you about the systems, the operations, and what kind of unexpected hurdles pop up working across so many places?
Well, it definitely highlights the constant need, right? Maintaining critical infrastructure at military bases, government sites worldwide. The challenge isn't just where, it's how.
How do you know?
Maintaining consistent standards, consistent security, reliable supply chains across different countries, time zones, legal systems, you name it.
Yeah, the logistics must be intense.
It's a logistical nightmare, frankly, even for big private companies. Doing this for complex, interconnected government systems globally, it's vital for national security, for daily ops. These aren't isolated buildings. They're nodes in a network.
Okay, let's dig into the actual work then. The PWS lists a whole bunch of activities. Beyond just restoring, what are some hands-on tasks that really show the technical depth here? Things that might surprise you.
Well, there's that retro commissioning we talked about, getting systems back to original parameters, but also doing detailed surveys, assessments, reviewing technical docs from other contractors.
Oh, GCs, right?
Other government contractors, yeah. And even buying special gear for testing and demos is pretty broad.
I'm seeing things like calibrating sensors, altering direct digital control systems, DDC systems, programming diagnostic apps. This is way more than just swapping a fuse, right?
Oh, absolutely. Highly specialized.
What kind of specific knowledge is needed for, say, altering a DDC system?
Deep knowledge of building automation, control sequences, programming logic for that specific system, which can vary widely. And then there's testing, adjusting, and balancing tab for HVAC, air, and water systems.
TTB?
Yeah, that's critical for efficiency and comfort. Fine-tuning airflows, water flows, it's precise work. Plus, configuring complex systems, tech support for data collection, and crucially, assessing equipment for information assurance IA standards.
Bridging the physical and the cyber.
Exactly.
And it even mentions incidental technical solutions like procuring and modifying UMCS or ESS components, controllers, sensors, cameras, card readers, switches. So they are buying new stuff sometimes. Doesn't that blur the line with that excluded new design work?
It can seem like it, but that word incidental is key.
Okay.
These purchases and mods are okay as long as they don't cross into that architect-engineer territory. It's about supporting the main service, getting systems back to peak performance. Sometimes that means integrating minor upgrades to meet current needs.
Right, not building something totally new from scratch.
Exactly. It's about making the existing system whole and functional again, maybe even slightly modernized as part of the restoration.
Okay. Now, given everything today, cybersecurity has to be huge here.
Absolutely central.
How does this contract handle that?
Yeah.
Especially with, older electronic and mechanical systems that maybe weren't built with today's cyber threats in mind.
That's a fantastic point, and it's a core challenge. These legacy systems, securing them is tough.
So what do they do?
The contractor provides really comprehensive support, helping get an authority to operate an ATO for systems, security engineering services, making sure there's a secure, compliant baseline with all the right documents.
Okay.
They might even provide people for roles like an ISO information system security officer or a configuration manager. The real trick is applying modern cyber frameworks to physical systems that might be old, proprietary. It's a constant adaptation game.
And what framework are they using for all this? Is it one size fits all?
Good question. How do you standardize this? They follow the risk management framework, RMF.
RMS.
Yeah,
Oh, yeah.
very structured lifecycle approach. They kick off RMF activities like registering systems in EMSS.
EMSS, that's the government tracking system.
Right. For managing security assessments, they assign cyber controls, put together authorization teams.
So it's definitely not a one-time setup. It sounds like a continuous process.
So absolutely ongoing. They implement controls, validate them with things like vulnerability scans, fix the findings.
Right.
And what's really interesting is they have to develop all the RMF paperwork policies, SOPs, training stuff.
Wow. Okay.
And prepare the plan of actions and milestones, the POA&M, for any leftover vulnerabilities. Then they have to maintain that authorization, constantly monitor the security posture, do regular reviews. Never really stops because the threats always change.
And they're doing this under a massive umbrella of regulations. You look at that list: Army regs, Air Force instructions, NIST, FSMA, DIDE stuff, DISA-STIGs. What's the biggest headache in keeping all that straight across so many different systems?
It's a huge list, you're right.
Yeah.
AIR 25.1, AIR 25.2, NIST 800 series, FSMA, DOD 8570.01 Acumen for Workforce, DISA STIGs.
STIGs, Secure Technical Implementation Guides.
Exactly. And the biggest challenge with STIGs, they aren't just general ideas, they are incredibly granular.
Like how granular?
Like specifying the exact password complexity allowed on a network-connected temperature sensor, or demanding you disable specific obscure network ports on a security camera.
Yeah.
It requires this obsessive attention to detail. And ensuring that level of precision consistently across a global portfolio of systems, old, new, different manufacturers, that's incredibly demanding. One tiny slip could be a vulnerability.
Yeah, I can imagine. This definitely sounds like you need a very specific, highly qualified team.
No question.
What kinds of pros are we talking about? What's unique about the qualifications needed?
Well, the PWS lists out quite a few key personnel. You've got your program manager, contracts manager, But then the really specialized engineers,
Like,
senior electrical mechanical engineer, senior electronic security system engineer, even a fire protection engineer. And on the IT cyber side, a lead IT cybersecurity manager, senior system security engineers, plus a quality control manager overseeing everything.
that blend of traditional engineering and cutting-edge cyber, that seems unique.
It really is. You need people who understand both the physical systems and the digital threats against them.
What kind of background certs are needed, especially for those cyber roles? Sounds like it's more than just a college degree.
Oh, definitely. Many roles need a bachelor's in engineering or similar, plus maybe 7-10 years relevant experience, often managing projects or teams.
Okay.
Senior engineers usually need a professional engineer's license, a PE. But for cyber roles, like that lead IT cyber manager or the senior system security engineers, they have to meet specific DoD directives.
Like 8140 and 8570.
Exactly. DoD Directive 8140.01 for cyberspace workforce management and 857.01 IM for the IA Workforce Improvement Program. And usually at high levels, like Level 3.
Level 3, what does that mean practically?
It means advanced certifications, things like CISSP, CISSM, maybe specific vendor certs, plus verified, hands-on experience securing complex government systems, way beyond standard commercial IT certs. And project managers typically need a PMP.
Okay. And the government isn't just trusting the contractor's resume, right? Seems like they're checking closely.
Precisely. The government reviews and approves these key people based on their own assessment, verifying the documents. The contracting officer has the final say.
So they can reject someone.
Absolutely. And the contractor can't just swap out key personnel without written consent beforehand. It ensures continuity, keeps that expertise locked in. It's a very hands-on approval process, showing how critical these roles are.
Makes sense. So with this critical work, how does the government actually ensure quality and safety across all these different jobs and locations?
It's basically a two-pronged approach, checks and balances.
Okay.
The contractor has their own responsibility. Quality Control Plan, or QCP. They create it, maintain it, make sure their work meets the PWS standards.
That's internal.
Right. Then, the government uses a Quality Assurance Surveillance Plan, QASP, to watch over the contractor's shoulder, essentially, to evaluate their performance.
Okay, the QAST. So what happens if something's not up to snuff? You mentioned these really tight deadlines for fixing things, 24 hours for critical issues.
Yeah, the Corrective Action Request System, the SOAR system.
Right. Is there a risk that fixing something that fast means it's not fixed thoroughly or that small stuff gets missed?
That's a fair question.
Yep.
The PWS tries to prevent that. The QASP defines what's acceptable, how they'll check. If there's a problem, they issue a CRR.
Critical, major, or minor?
Exactly. Critical nonconformance could be hazardous 24 hours to respond and propose a fix. Major affects usability 72 hours. Minor maybe 15 business days.
Then if they don't meet that?
Penalties.
Yeah.
Could be reduced payments, bad performance reviews, even ending the contract. The pressure is definitely on for immediate and thorough fixes. The oversight is designed to catch corner cutting.
Okay. And beyond quality, safety has to be huge. Working with electricity, heavy gear.
Paramount. Everything has to follow the U.S. Army Corps of Engineers Safety Manual, EM 38511.
That sounds serious.
It is. Very detailed. They need an abbreviated accident prevention plan just for a site visit.
Okay.
A full site-specific accident prevention plan before doing any real installation work.
Wow.
And for really hazardous screen lifts, high voltage, you need a full-time site safety and health officer and SSHO right there, plus monthly safety reports on injuries, hours worked. It's a very strict safety culture.
Okay, and one last piece. The security of the people themselves and the sensitive info they're handling inside these facilities. Lots of checks there, too.
Multiple layers, absolutely.
Right.
Everyone needs basic 8-level eye awareness training just to get on an Army installation.
AT, anti-terrorism.
Wow. Then for IT access, U.S. citizens need designations ITI 2 or 3, which trigger background checks, SSBI and ACLC. Depends on the level. And they need a common access card, a CAC.
What about non-U.S. citizens?
You need approval from the USC HQ Foreign Disclosure Officer. Plus, everyone gets training like IWAT Cheat Core Watch reporting suspicious stuff, Threat Awareness Reporting Program, TARP training, and they use E-Verify for checking employment eligibility.
And classified info.
Whole other level. Contractor needs a facility clearance. Personnel need individual clearances. Anyone without a clearance needs an escort at all times in secure areas. It's exhaustive, covering personnel, physical, and information security.
Okay, so we've really dug into what looks like, a pretty dry government document. What's the big takeaway here for you, the listener? Why does understanding this level of detail matter?
I think this deep dive really shows the massive, often invisible effort that goes into keeping critical infrastructure running. Stuff that impacts our daily lives, national security, from the global reach, the super specialized skills, those intense security and quality rules. Every bit of this document is about ensuring reliability, safety, efficiency, whether it's the AC in a command center or the cybersecurity protecting sensitive
It's
data.
like a hidden army, as you said.
Exactly, quietly keeping everything humming.
It really drives home that these complex systems we rely on depend on this intricate web. Specialized skills, rigid standards, constant, careful oversight. So maybe next time you hear critical infrastructure, you'll think about this detailed work, these experts behind the scenes.
Yeah. And it leaves you with a pretty important question, I think. As technology just keeps accelerating, systems get even more connected, more complex. How do requirements like these, so detailed and comprehensive now, adapt? How do we make sure critical systems stay secure and functional against threats and innovations we haven't even seen yet?
What new, unseen complexities are just around the corner?
Exactly. That's the ongoing challenge.